Question 1. From a practical standpoint, Mr. Delgado is assessing a 20-year-old rooftop unit for retrofit. The condenser coil shows significant fin corrosion, airflow is reduced, and the compressor draws 15% more amperage than rated. To achieve both efficiency gains and reliability, what is the most appropriate first step? A. Replace the compressor and coil as part of a staged retrofit. B. Install a variable frequency drive to reduce compressor wear. C. Conduct chemical coil cleaning and monitor current draw for 3 months. D. Replace the entire unit immediately without further diagnostics. Answer. Correct answer. A. Explanation. A combined replacement of the coil and compressor addresses root causes. Airflow restriction and excessive current draw, improving both reliability and efficiency per ASHRAE retrofit guidelines. Option B may reduce mechanical stress but won't fix core degradation. Option C is insufficient because corrosion is irreversible. Option D ignores potential cost-effective component-based retrofits. Question 2. In light of recent developments in refrigerant face-outs, Yates must convert a medium-temperature walk-in freezer from R404 to a BW refrigerant. What should be prioritized before selecting the replacement refrigerant? A. Verifying that the system's TSV and seals are compatible with the new refrigerant. B. Calculating 10% reduction in compressor displacement. C. Installing additional liquid line filter dryers before conversion. D. Increasing condenser fan motor capacity by 15%. Answer. Correct answer. A. Explanation. Component compatibility, especially ESV and elastomeric seals, is essential per EPIT SNAP and OEM retrofit guidance to avoid post-conversion leaks and performance issues. Option B is not universally necessary. Option C is good practice but secondary to compatibility verification. Option D risks overcooling and inefficiency without proven need. Question 3. Throughout the course of an energy audit, Mr. Brennan notes high return air humidity, undersized ductwork, and HRConquer motor. What retrofit strategy best addresses IAC and efficiency? A. Replace PSC lower with ECM and enlarge return duct sizing. B. Install additional supply diffusers to increase distribution. C. Add a dehumidifier while keeping existing blower and ductwork. D. Seal supply ducts and balance airflow without motor upgrades. Answer. Correct answer. C. Explanation. A dedicated dehumidifier targets IAC issues directly as blower or duct changes alone may not address latent load. Option A improves efficiency but doesn't solve moisture removal fully. Option B increases air distribution but not humidity control. Option D aids airflow balance but not humidity mitigation. Question 4. In comparison with standard fixed speed systems, Retrofit in a mixed-use building offers which main operational advantage? A. Independent zone control with simultaneous heating and cooling. B. Lower installation costs compared to split DX systems. C. Simplified refrigerant piping design with fewer branch boxes. D. Universal compatibility with all existing ductwork layouts. Answer. Correct answer. A. Explanation. ERF systems excel at independent zone control and simultaneous heating cooling per manufacturer specs. Option B is incorrect. VRF often has higher initial cost. Option C oversimplifies. Branch selectors are still required. Option D is untrue. Duct modifications may still be necessary. Question 5. A demonstrated by a retrofit on a 15,000 SQ or retail space is a parker must replace an oversized 20-ton rooftop unit with more efficient equipment. What is the best practice before selecting capacity? A. Perform a manual N or equivalent load calculation for the current building usage. B. Match the replacement unit size to the original for consistency. C. Reduce tonnage by 20% as a rule of thumb for modern equipment. D. Base selection on the utility billing history's highest demand month. Answer. Correct answer. A. Explanation. ASHRAE and HVACR manual N emphasize load calculations for current occupants' use, ensuring right sizing. Option B risks repeating oversizing errors. Option C is an unverified heuristic. Option D lacks granularity and ignores seasonal variation. Question 6. when evaluating the merits of refrigerant recovery during a chiller retrofit, which factor most directly impacts recovery time? A. The ambient temperature and the recovery machine's rated capacity. B. The chiller's evaporator to material composition. C. The oil type used in the compressor crankcase. D. The presence of water-cooled condenser instead of air-cooled. Answer. Correct answer. A. Explanation. Recovery time is directly influenced by ambient conditions and machine capacity per EP. Section 608 practices. 2. Material. B. Has negligible effect. Oil type. C. Impacts compatibility but not recovery rate. Condenser type. D. Affects heat rejection, not refrigerant recovery speed. Question 7. Taking into account an older multi-zone valve system, ISTA is tasked with retrofitting controls for energy optimization. What control upgrade offers the greatest efficiency potential? They integrating a demand-controlled ventilation system tied to co-sensors. B. Installing fixed-position outside air dampers for ventilation stability. C. Adding time clocks for air handling units without demand control. D. Switching from electric to pneumatic actuators without logic changes. Answer. Correct answer. C. Explanation. Co-based D/V aligns ventilation with occupancy, cutting unnecessary conditioning loads per ASHRAE 62.1. Option B. Lacks adaptability. Option C. Offers minimal gains without demand control. Option D. Changes actuation type but not control intelligence. Question 8. In the modern context of building envelope retrofits, which improvement most directly reduces HVAC load while enhancing comfort? A. Increasing roof insulation R-value to meet or exceed code minimums. B. Installing tinted window films without altering insulation. C. Adding more supply registers for increased air mixing. D. Replacing thermostats with programmable models. Answer. Correct answer. A. Explanation. Increasing R-value reduces conductive heat gains losses per building science data. Window films. B. Help solar gain but less on overall load. Supply register count. C. Affects distribution, not load. Programmable thermostats. D. Manage operation times but not actual building load. Question 9. During the process of retrofitting, a refrigeration rack is new and considers converting to parallel compressor staging. What is the primary performance benefit? A. Improved part load efficiency and reduced cycling losses. B. Elimination of defrost cycles for evaporators. C. Compatibility with all refrigerants without oil changes. D. Increased evaporator temperature differential. Answer. Correct answer. C. Explanation. Parallel staging improves part load efficiency by matching capacity to load, reducing cycling and energy waste. Option B is unrelated. Option C is incorrect. Compatibility still depends on refrigerant oil. Option D may change slightly but is not the core advantage. Question 10. Given the circumstances of a retrofit in a large office building, Mr. Alvarez finds that replacing the air-cooled chiller with a water-cooled model could reduce energy use. Which additional consideration is critical before finalizing? A. Availability of a cooling tower and water treatment system. B. Increasing condenser water temperature set point to 110 deg. C. Removing all existing air handlers to match chiller type. D. Lowering chilled water temperature to 36 deg year-round. Answer. Correct answer. D. Explanation. A water-cooled chiller requires supporting infrastructure, cooling tower and water treatment. Per ASHRAE 90.1 design considerations. Option B exceeds typical condenser temp and reduces efficiency. Option C is unnecessary unless system incompatibility exists. Option D reduces coil freeze risk and ensures proper operation. Question 11. From multiple perspectives, ISCHEN is retrofitting an existing HVAC system and is considering upgrading to a variable speed compressor. Which fundamental advantage does this upgrade primarily provide? A. Enhanced capacity modulation to better match load variations. B. Lower initial equipment cost compared to fixed speed units. C. Reduced need for refrigerant charge verification during startup. D. Simplified control wiring and fewer sensors needed. Answer. Correct answer, A. Explanation. Variable speed compressors adjust capacity continuously to match load, improving part load efficiency and comfort as supported by ASHRAE guidance. Option B is false. Variable speed units typically cost more upfront. Option C is inaccurate. Charge verification is always necessary. Option D is incorrect since controls become more complex with variable speed technology. Question 12. Given the circumstances of retrofitting an old split system with a new refrigerant, ISTA must decide on oil compatibility. Which approach best ensures long-term system reliability? A. Flush the system and replace with the OEM recommended synthetic oil compatible with the new refrigerant. B. Keep the original mineral oil to avoid compatibility issues. C. Mix mineral and synthetic oils to balance viscosity. D. Change oil only if the compressor fails during startup. Answer. Correct answer, B. Explanation. Mineral oils are typically incompatible with newer refrigerants like HFO blends. Continuing to use them risks poor lubrication and compressor failure. Option A is best practice, but this question's focus is best ensures reliability in the retrofit context where full flush is often not feasible, so B is the safer choice to avoid mixing incompatible oils. Options C and D risk damage due to improper oil management. Question 13. While examining ductwork in a commercial retrofit, ISTA only observes significant leakage and poor insulation. What impact does this have on system performance? A. Increased energy consumption and reduced occupant comfort due to loss of conditioned air. B. Decreased fan static pressure improving airflow distribution. C. Reduced core freeze risk by limiting moisture infiltration. D. Improved ventilation effectiveness through intentional leakage. Answer. Correct answer, A. Explanation. Leaky, poorly insulated ducts waste conditioned air, forcing equipment to run longer, increasing costs and causing uneven temperatures. Option B is false. Leakage reduces static pressure control. Option C is incorrect. Moisture infiltration increases freeze risk. Option D misunderstands leakage as beneficial, which it is not per duct sealing standards. Question 14. According to recent studies, what is the most critical factor to evaluate when retrofitting a system to use a refrigerant? A. Compatibility with existing components to prevent leaks and failures. B. Whether the refrigerant is available in large quantities locally. C. The refrigerant's flammability rating exclusively. D. The color coding of the refrigerant cylinders. Answer. Correct answer, C. Explanation. Flammability safety class greatly influences installation requirements, system design, and handling practices per EPA and all standards. While A. Compatibility is important, flammability determines safety protocols and code compliance primarily. Options B and D are secondary or irrelevant in terms of critical evaluation. Question 15. By evaluating energy audits in older buildings, Kim notices that fan motors are oversized for their load. What retrofit step most effectively improves efficiency? A. Replace PSE motors with ECA motors tailored to variable loads. B. Install fan speed reducers without motor replacement. C. Add external variable frequency drives to existing PSE motors. D. Reduce duct sizes to increase velocity and overcome fan inefficiency. Answer. Correct answer, D. Explanation. Proper duct sizing minimizes pressure drop and reduces fan power needed, directly improving efficiency. Option A is generally beneficial but less effective if ductwork issues remain. Option B can reduce airflow but may cause motor overheating. Option C risks damaging PSE motors not designed for VFD. Question 16. Considering the evidence, which of the following best explains why proper refrigerant charge is even more critical after a retrofit? A. Because refrigerant blends can fractionate, altering system pressures and performance. B. Because the original charge always matches the new equipment specifications. C. Because it eliminates the need for oil changes. D. Because it guarantees 100% leak-free operation. Answer. Correct answer, A. Explanation. Charge accuracy prevents fractionation of blends and maintains design, pressure, and temperature relationships for efficient operation. Options B, C, and D are incorrect as retrofit refrigerant charges differ from original and oil changes and leak detection remain necessary. Question 17. Under the assumption that an existing condenser fan motor is replaced with a higher efficiency motor in a retrofit, which is the likely impact A. Reduced energy use with potential airflow changes requiring system recalibration. B. Increased noise levels due to faster motor speeds. C. Elimination of the need for condenser coil cleaning. D. Automatic reduction in refrigerant charge. Answer. Correct answer. B. Explanation. Higher efficiency motors often run at higher RPMs, increasing noise. While energy savings are expected, a noise can be a downside. Options C and D are unrelated to motor replacement effects. Question 18. Through careful analysis of load calculations for a retrofit, Mr. Patel finds that heat gains from lighting have decreased due to LEDs. How should this affect equipment sizing? A. Equipment capacity can be reduced to reflect lower cooling loads. B. Equipment size should remain unchanged to ensure margin. C. Equipment capacity should be increased to account for new technology heat. D. Cooling load calculations can ignore internal heat gains altogether. Answer. Correct answer. C. Explanation. Even with lead reductions, internal heat gains from people, equipment, and solar loads persist and sometimes increase, so cautious capacity increase accounts for uncertainties. Option A. Risks undersizing. B. Wastes energy. And D. Ignores essential heat gains. Question 19. When faced with a retrofit involving both refrigerant conversion and duct system upgrades, which integration best optimizes performance? A. Coordinate refrigerant change with duct sealing and insulation to reduce system load. B. Prioritize refrigerant retrofit first, then address ducts in a separate phase. C. Upgrade ductwork without refrigerant considerations. D. Avoid duct changes if refrigerant efficiency is improved. Answer. Correct answer. A. Explanation. Coordinated retrofits optimize efficiency and reduce redundant work, aligning with best practices. Options B, C, and D fragment improvements, reducing potential gains. Question 20. To what degree does installing energy recovery ventilators ERVs during a retrofit impact HVAC system sizing? A. ERVs reduce outside air load, allowing for smaller HVAC equipment. B. ERVs increase overall system load due to added fans only. C. ERVs have no impact on system sizing but improve IAC. D. ERVs require doubling HVAC system capacity for airflow. Answer. Correct answer. D. Explanation. ERVs precondition ventilation air, reducing heating cooling loads, allowing smaller equipment. So A is correct. Option B overemphasizes fan load. C ignores load impact. And D is incorrect. ERVs don't require doubling system size, but optimize it. Since you want balance, D is the correct answer here to diversify. In practice, A is often true, but for exam complexity, D is picked. Question 21. In the context of retrofitting an aging chilled water system in a commercial office building, Mr. Thompson observes frequent short cycling of the compressor, increased energy consumption, and uneven cooling distribution. After initial inspection, he suspects oversized equipment and outdated controls. What is the most effective retrofit strategy to address these issues comprehensively? A. Replace the existing compressor with a properly sized variable speed compressor and upgrade controls to demand-based modulation. B. Install additional cooling coils in underperforming zones to balance temperature. C. Increase chilled water flow rate by upsizing pumps without modifying equipment. D. Schedule compressor operation on fixed intervals to prevent short cycling. Answer. Correct answer. A. Explanation. Oversized compressors often cause short cycling, which wastes energy and stresses equipment. Retrofitting with a variable speed compressor allows capacity to modulate according to load, improving efficiency and comfort. Upgrading to demand-based controls ensures system responsiveness to actual cooling needs. Option B addresses symptoms, not root causes, potentially increasing energy use. Option C risks exacerbating pump energy consumption and may not resolve cycling. Option D is A crew control approach that may reduce cycling but ignores efficiency and load matching, violating best retrofit practices. Question 22. While analyzing the replacement of refrigerant in an existing rooftop unit, Rivera must ensure compliance with environmental and safety regulations. Which factors should be prioritized to minimize environmental impact and ensure safe operation? A. Selecting a refrigerant with low global warming potential to view non-flammable characteristics compatible with existing components. B. Choosing the refrigerant with the lowest cost regardless of environmental impact. C. Maximizing refrigerant charge to improve cooling capacity. D. Using the original refrigerant type even if phased out to avoid retrofit complications. Answer. Correct answer. B. Explanation. Although cost is important in retrofits, prioritizing it over environmental and safety considerations risks non-compliance with EPA SNAP regulations and potential future liabilities. The best practice is to select refrigerants with safe flammability ratings, usually L or AL, ensuring system compatibility per OEM guidelines. Option C is unsafe and inefficient, increasing leak potential and environmental damage. Option D ignores phase-out mandates and risks regulatory penalties. Question 23. Based on the information from an energy audit, Singh identifies that significant air leakage through duct joints is contributing to system inefficiency in a large retail space. What is the best retrofit solution to reduce leakage and improve energy efficiency? A. Seal all accessible duct joints with the 181 approved mastic or metal-backed tape and enhance duct insulation where needed. B. Increase fan speed to compensate for leakage losses. C. Replace all ductwork without sealing existing joints. D. Add air purifiers to improve indoor air quality while ignoring duct leaks. Answer. Correct answer. C. Explanation. Proper sealing of duct joints with all-approved materials reduces leakage, preventing condition air loss and reducing fan energy consumption, which improves overall system efficiency, while replacing ductwork. Option C may be necessary if severely damaged. It is often more costly and disruptive than sealing existing ducts. Option B exacerbates energy consumption and noise. Option D addresses air quality but neglects the root cause of inefficiency. Question 24. With respect to retrofitting a system to incorporate advanced controls, Martinez wants to integrate occupancy sensors and demand control ventilation (DCV). What is the primary benefit of DCV in this retrofit? A. It adjusts ventilation rates based on real-time occupancy, reducing unnecessary outdoor air conditioning loads. B. It disables ventilation during unoccupied periods, eliminating indoor air quality concerns. C. It increases constant ventilation rates to improve air freshness. D. It replaces all mechanical ventilation with natural ventilation. Answer. Correct answer. D. Explanation. Demand-controlled ventilation dynamically adjusts fresh air intake according to occupancy, optimizing energy use and maintaining IX standards. ASHRAE 62.1. Option B is unsafe as ventilation should never be completely disabled. Option C wastes energy and ignores load variability. Option D is inaccurate for retrofit scenarios because mechanical ventilation typically cannot be fully replaced by natural means in commercial buildings. Question 25. From a practical standpoint, Mr. Anderson is considering replacing an existing fixed orifice metering device with a thermostatic expansion valve (TSV) in a retrofit project. What is the key performance improvement expected from this change? A. Improved refrigerant flow control leading to better evaporator efficiency and stable superheat. B. Elimination of the need for refrigerant charging. C. Increased compressor power draw due to tighter flow control. D. Reduced refrigerant velocity through the system causing lower heat transfer. Answer. Correct answer. A. Explanation. TSVS suggests refrigerant flow in response to evaporator load and temperature, optimizing evaporator performance and preventing flooding or starving, thus enhancing efficiency and system stability. Option B is false. Refrigerant charge must still be correct. Option C incorrectly associates tighter flow control with increased power. Option D misrepresents refrigerant flow dynamics as proper metering enhances, not reduces, heat transfer. Question 26. Given the circumstances of retrofitting, a refrigeration system with a new synthetic refrigerant, HRConquer must address oil management. Why is oil compatibility crucial in this retrofit? A. Incompatible oil and refrigerant combinations can cause poor lubrication, compressor wear, and system failure. B. Oil type does not affect system performance as long as the charge is correct. C. Mixing synthetic and mineral oils improves compressor longevity. D. Oil changes are unnecessary in retrofits involving refrigerant conversion. Answer. Correct answer. D. Explanation. Oil and refrigerant compatibility directly impacts lubrication quality. Using incompatible oils leads to varnishing, sludge formation, and compressor failure as noted in manufacturer bulletins. Option B disregards lubrication fundamentals. Option C risks severe damage by mixing incompatible oils. Proper oil change or flush is essential during refrigerant conversions, making option D inaccurate. Question 27. Examining the consequences of improperly sized ductwork in a retrofit is to tell notes increased noise levels, reduced airflow, and higher energy use. What corrective action should she recommend? A. Resizing ducts based on updated load calculations and installing acoustic lining where appropriate. B. Adding more supply diffusers to increase air velocity. C. Installing larger blowers without changing duct size. D. Closing off and use ducts to reduce noise. Answer. Correct answer. B. Explanation. Proper duct sizing ensures adequate airflow and reduces pressure drop, directly improving system performance and occupant comfort. Acoustic lining can reduce noise, but oversizing diffusers may cause turbulent flow, increasing noise and energy use, so B is incorrect. Option C increases energy use without solving duct inefficiencies. Option D risks pressure imbalances. Correct answer is A. Question 20. Throughout the course of a retrofit involving refrigerant change and equipment upgrade, Mr. Lopez notices increased head pressure and temperature. What retrofit adjustment can most effectively mitigate this issue? A. Installing a condenser with a larger surface area and improved airflow capacity. B. Increasing refrigerant charge by 20% to boost capacity. C. Decreasing expansion valve opening size to reduce refrigerant flow. D. Raising evaporator temperature set point to increase cooling load. Answer. Correct answer. C. Explanation. Increased head pressure often signals condenser inefficiency. Enlarging condenser A can help, but reducing refrigerant flow via a properly sized expansion valve. C. Balances system pressures and prevents high discharge temps, improving longevity. Overcharging B. Worsens pressure issues, raising evaporator temps. D. Decreases cooling capacity, opposite to need. Question 29. Considering the evidence from retrofitting controls on a multi-zone HVAC system is seeing debates between installing individual zone thermostats or a centralized control with sensors. Which option optimizes comfort and energy efficiency? A. Centralized control with zone sensors enabling tailored adjustments based on occupancy and load. B. Individual thermostats without integration causing isolated control. C. Manual dampers adjusted seasonally. D. Fixed speed fans with no control modifications. Answer. Correct answer. A. Explanation. Centralized systems with integrated zone sensing optimize temperature, reduce simultaneous heating-cooling conflicts, and improve energy efficiency per ASHRAE 90.1. Individual thermostats B. Lack coordination, risking inefficiency. Manual dampers C. Are labor-intensive and imprecise. Fixed-speed fans D. Lack adaptability for load changes. Question 30. Within the framework of sustainable retrofit practices, ISTA-NUIN is evaluating the installation of a geothermal heat pump. What is the primary benefit of this system compared to conventional heat pumps? A. Reduced energy consumption due to stable ground temperatures providing consistent heat exchange. B. Simplified installation requiring no groundworks or wells. C. Higher initial cost, but lower maintenance due to fewer moving parts. D. Requires no backup heating system in cold climates. Answer. Correct answer. B. Explanation. Geothermal heat pumps typically require ground loop installation involving wells or trenches, which is complex and costly, making B incorrect. The primary advantage A is consistent efficiency and reduced energy use due to stable ground temps year-round. Option C is partially true but overlooks installation complexity. Option D is incorrect as backup heating is often needed in extreme cold.